So this time, Charles' law, same apparatus here, temperature probe in here, but we're not logging it with a PC this time, just reading straight off the meter because we're using the gas syringe to measure a change in volume, and hopefully we should find out that volume is proportional to temperature there. We had some issues because this gas syringe was like jumping, so rather than increasing linearly and steadily, it jumped in certain gaps. So the first time what we did was we waited for certain whole numbers of temperature and recorded the volume change on the gas syringe. But the second time through, what we did was we actually recorded the temperature every time we saw it jump. So it jumped, we recorded what it was on here, recorded what it was on there. So we've got a nice continuous set of data on our iPad here, which the students are going to analyse now and hopefully find out that absolute zero is indeed minus 273. So what we're doing is we're using the spreadsheet to plot volume versus temperature on a graph like this, and then the computer is doing a trend line for us, which we are going to extrapolate back through the y-axis all the way back to find the x-intercept. So you're used to working with y-intercepts quite a lot, but we're trying to find the x-intercept today. Excel then works out y equals mx plus c line equation for a line for us, and we can use that to work out what that y-intercept is going to be, which is our theoretical absolute zero. So in this case, if I rearrange, making y 0, of course, because the x-intercept is going to be at y equals 0. So x then is minus 83.759 divided by the gradient 0.4118, and that actually comes out at minus 203.4 degrees C. So that's not too bad for in the lab where we're actually extrapolating out quite a lot of experimental uncertainty. We would not really expect to be closer than that to absolute zero. Not bad at all. So this is our raw data for the spherical flask and the temperature sensor and the gas syringe. So we've got temperature here and change in volume there, and then we've added the volume of the syringe and the connecting pipe for here. So we've got a graph here of V versus T, and Excel actually just gives us a line of best fit and an equation for that line of best fit. So when we sum that round, we're interested in the x-intercept here. Temperature is on the x-axis. So we're interested in the x-intercept, which is going to be absolute 0. So rearrange when y equals 0, and therefore x equals minus 390.
You can't see it.
There it is. 391. Minus 391. That's not great for absolute 0. So we had a little look into the data as well, and we can see that the line is actually straighter in this middle kind of section of the graph. So what we did was we thought, well, that's going to be our most accurate section, if you like. Here, the glass and everything's heating up with the mantle. Here, maybe the temperature, the rate of energy transfer isn't quite as high because temperature difference isn't so great. So we used sheet 2, and we just took the same data, but just used that straighter line section that we could. And here's our new equation there. Y equals 1.83 x plus 461, and summing that round for absolute 0 gives minus 252 degrees C, which is pretty close considering the real thing is 273, minus 273. Alright, that's some successful physics. So this is the apparatus that we used for measuring the change in volume with temperature. Okay, I hope you can see there's actually a little trapped bit of mercury in a capillary tube, which is mounted on a ruler with a thermometer next to it, and therefore you can measure the temperature and the change in volume, or the volume itself, because you've got that trapped bit of gas in there, in that capillary tube, and hopefully you're going to get a straight line like that. Now this student here is actually getting on and he's looking at data for all, how many did we do?
6.
6 of these. and we actually did them all in one large beaker of water rather than one thermometer, and we're getting an average, and it's allowed us to see an anomalous line, which is the blue one at the bottom there, and that means that we're just going to exclude that. I think we'll do our average, aren't we? So you're going to get a line about, you're going to get the trend line equation for each one and average those, and hopefully we'll get even closer than minus 203.4.